Ever get that feeling, where you learn something new and it kind of just changes your whole perspective?
Yeah, like a real aha moment.
Exactly. And today's deep dive, well, it has the potential to be one of those. We're diving deep into this new AI system. They're calling it O1. And get this, it's not just about predicting text like some of the AI we've seen before.
Right, it's actually designed to reason.
Yeah, reason. It's a whole different ballgame. And this research paper you shared, it really digs into whether AI, even when it's built for this complex reasoning, can ever really break free from, like, the shadow of its early training.
It's a really fascinating question, and O1 is a perfect test case. I mean, it's pushing the boundaries of what we thought AI could do, but then this research comes along, it's like, hold on, are there still these lingering traces, kind of like echoes of its initial training?
Okay, so we're talking about a system that's supposed to think for itself, but this research suggests there might be these hidden biases or preferences
Yeah.
based on the massive amounts of data it was trained on.
Exactly. It's like, imagine you're training a dog, right? You reward certain behaviors, and they become ingrained. But then, what happens when you throw a curveball, a new situation that's similar but not quite the same? The dog's initial training might still influence how it reacts.
So are we saying something similar might be happening with O1, even though it's designed for reasoning? It might still be kind of stuck on those early lessons?
That's the core idea here. The study uses this really interesting term. They call it embers of autoregression.
Embers of autoregression. Okay, I like that.
It's like those embers are still glowing even when the fire has died down, and they can still influence how the AI operates, even in these more sophisticated tasks.
So how do we even begin to unpack that? How do you study those embers, those hidden influences in something as complex as O1?
Well, the researchers took a really interesting approach here. They looked at it from what's called a teleological perspective.
A teleological perspective. Now that sounds complicated.
It's actually simpler than it sounds. It just means trying to understand a system by looking at the pressures that shaped it. So in this case, it's about understanding how Owen's early training, feeding it all that language data, might still be influencing it, even when it's doing these complex reasoning tasks.
So it's like saying to understand how someone thinks, you need to know their background, their experiences.
Exactly. And this research suggests that AI, even advanced AI like O1, might be shaped by its past in a similar way.
Okay, now that's a thought-provoking idea. And I'm guessing that's where these experiments come in, right? They
Mhm.
design these experiments to see how those embers might actually play out in how O1 performs.
You got it. And that's where things get really interesting. They came up with these clever ways to test O1 to see if they could, in a way, tease out those hidden influences.
All right, so walk us through it. How do they actually test this whole ember theory with O1? What did those experiments look like? So how did they test this whole ember theory? What did these experiments look like?
Well, one of the things they did was they gave O1 tasks, where the answers could be like really common phrases, things we hear every day, or they could be these like super unusual word combinations, almost like, if you were unscrambling letters to spell a word, and it was either going to be sunshine or like some obscure scientific term you'd never use in everyday conversation.
Okay, and so what happened? Did O1 handle both types of answers equally well?
Well, that's the thing, right? While O1 could technically handle both, there was this noticeable difference, like it was smoother, faster, when it was generating those common expected phrases.
Ah, so even though it's built for reasoning, it still shows this kind of bias towards what's more statistically likely, what it's seen a lot of in its training data.
Exactly. And to really measure this objectively, they looked at, get this, thinking tokens.
Thinking tokens.
Yeah, essentially it's a way to like quantify how much internal processing O1's doing for a task. Kind of like a measure of its mental effort, if you will.
Okay, so more thinking tokens means it's having to work harder to find the answer.
Exactly. And consistently, when it had to deal with these, less common phrases, it used more thinking tokens. It's like, imagine you have to navigate a maze, right? The familiar path is always going to be faster than exploring every dead end, even if you get there in the end.
I'm with you. So even in those complex tasks, those embers of its early training, that massive data set it learned from, it still plays a role. But they didn't just stop there, did they? What other tests did they do with O1?
They also wanted to see how it handled different types of tasks, some way more common than others. Think about something like I don't know, sorting a list alphabetically. Pretty standard stuff, right?
Yeah, we do that all the time without even thinking about it.
Exactly. Now imagine asking O1 to sort that same list, but in reverse alphabetical order. Still doable, but definitely like less common, might require a different thought process, right?
Okay, I see where you're going with this. So they threw both common and uncommon tasks at O1. What happened?
And, initially O1 seemed totally unfazed. It aced both types of tasks, like it was saying, give me any sorting challenge you got. But then the researchers, they made things even more interesting.
Okay, here comes the plot twist. What did they do?
Hmm.
They cranked up the difficulty, right? Made those uncommon tasks even trickier.
Exactly. And that's where things took an interesting turn. As those less common tasks became more challenging, O1 started to show signs of strain. It wasn't as effortless as before.
So even though it's this powerful reasoning machine, how often O1 encountered a certain type of task during its initial training still seemed to matter. That's pretty profound when you think about it.
It really is. It suggests that even when we design AI for sophisticated tasks, those early experiences leave a kind of imprint, influencing how it tackles new challenges. It's like if you've only ever driven in areas with grid systems, navigating a city with winding roads and roundabouts might require more effort, even though you're a skilled driver.
So where does this leave us? We've got O1, this incredible leap forward in AI, but even it's showing these embers of its past. What's the big takeaway here?
I think the biggest takeaway is that understanding how AI learns and evolves is just as important as developing its technical capabilities. This research shows us that even when AI is designed for reasoning, those early experiences with language are deeply intertwined with its abilities.
It's like we can't just assume that feeding an AI tons of data and setting it loose on complex problems will erase the influence of that initial training. These embers might still be lurking beneath the surface.
Absolutely. And that awareness is crucial. It highlights the need for ongoing research into how we can develop AI systems that are not only powerful, but also transparent and reliable.
It makes you wonder, though, if those early patterns are so persistent, could we actually use that to our advantage? Could we intentionally prime AI with specific information to excel in certain fields?
That's a fascinating question. It's like asking if we can tailor AI's thought patterns by carefully selecting its early training data. Could we create an AI that excels at medical diagnosis by priming it with medical texts, or one that's a whiz at architecture by training it on blueprints and design principles? It's a tantalizing possibility, and I'm certain researchers are already exploring the potential of this discovery.
It sounds like we're on the verge of a whole new era in AI development, one where understanding and even harnessing these embers could be the key to unlocking even greater potential. So much to think about. This deep dive has certainly given us a lot to ponder. Thanks for walking us through it. It's been illuminating.